Hi there and welcome to tutorial 10 on bivariate data, and this is for the Edexcel S1 A-level module. As always, it's applicable to most other exam boards, and if you're looking for further help, do check out youtube.com/Mr. Arnold's Maths. Bivariate data is the study of statistics where we have two variables to worry about, and you would have come across this at GCSEs, most notably in scatter diagrams. So when we're drawing scatter diagrams, you should know this already. We're going to have one variable on the x-axis, one variable on the y-axis. We can plot it like we would plot coordinates on a grid. So if I plot the number of cans against the number of fillings, we get 2, 1, 3, 3, 4, 3, 5, 4, and 6, 5. And we can see there seems to be some sort of relationship that as the number of fizzy drinks goes up, so does the number of fillings. And this is what we call a correlation. So there's different types of correlation. We have positive correlation. That's where as one variable increases, so does the other. And we've got negative correlation, so as one variable increases, the other variable seems to decrease. And then we have no correlation. That's where there's no apparent linear relationship. Now, just because there's no linear relationship does not imply there is absolutely no relationship at all. But for the S1 course, we just have to worry about linear correlations. So we have variability in bivariate data. So if you remember back in one of my earlier videos, I described the variance as sigma squared, and that was calculated by working out the mean squared distance. So what we did was we take each x value, subtract the mean, square it, add them all together, and then divide by n, and that gave us the variance. In bivariate data, we have this SXX term, which basically means the sum of xx, and that is given by sigma x minus x bar all squared. So this top bit is actually SXX over n. And we can do that with the y variable, and we can also work out what's called the covariance. Covariance, that's the variance of the x with respect to the y, and that's calculated using this. Now, these are all given in the formula book, but we can simplify them, and this is also given in the formula book. If I know that sigma squared is given by this, well, that implies that n times sigma squared equals the sum of x minus x bar squared. So in other words, SXX is given by n times sigma squared. You may also remember that sigma squared, I'll do it over here, sigma squared is given by the mean of the squares minus the square of the mean and if I know that SXX equals this, that implies that n multiplied by all of this, so let's put this in here, mean of the squares minus the square of the mean, that square sign should not go there. There we go, and multiplying the n in, we get n times sigma x squared over n minus, I'm going to have n times sigma x to be squared over n squared, and that can simplify because these two cancel out. We get sigma x squared minus, and an n cancels out here, we get sigma x all squared divided by n, and that is the formula for SXX. Similar, we can do a similar thing then with SXY and SYY. These are all given in the formula book, like so. So let's have a go at using one of these formulas. So we're given the head circumference in centimeters and gestation period in weeks for newborn babies, and we're asked to work out SXX for these data. So let's just remind ourselves briefly of the formula. So that's the formula we're going to use, and I'm going to show you how to do this using the calculator, because the calculator is going to do all the hard work here. So let's bring out the calculator, and you notice to start, the calculator is just in regular math mode. So I'm going to change the mode to statistics. So I press mode, then 3 to change to statistics. It's not single variable. We're actually doing 2 variable. So I'm going to go choose 2. And I'm going to enter my X and Y values. So I'll call these ones X and these ones can be Y. So 31.1. And the Y value was 36. 33.3. 37, 30, and 38, 31.5, and 38, 35, 40, and 32, 30.2, and 40. And don't worry about this being like a seventh term. It won't be calculated so long as I left blank. So once they're entered, I hit AC. And now I can use the calculator to get the various pieces of information I want. Okay, so if I hit Shift and then 1, I'm given the option here for some statistics. I can get the sums, which is what I'm looking for. So we'll start with the sum of X. If I hit 2 and then equals 191.1. So sum of X equals 191.1. Shift stat sum again, sum of X squared, 6105.39. 6105.39. I'm going to get the sum of y's. Again, following the same thing. Shift 1, sum of y's, so that's number 4. 229. And then sum of y squared. Shift 1, sum, and then 3. 8753. And then finally we're going to need the sum of xy. Shift 1, sum, and then number 5 gives me the sum of xy. 7296.7. Okay, so to work out SXX, we just plug the values into the formula. So I need the sum of x squared, that comes from here. 6105.39 minus the sum of x squared, so 191.1 squared, divided by n, which is 1, 2, 3, 4, 5, 6. You've got 6 bivariate data points. We'll plug that into the calculator. 6105.39 minus 191.1 squared divided by 6. You get 18.855. So I'm going to write that down. 18.855 5. You might have noticed there when we're in statistics mode, when I try and hit the fraction button, I get this kind of backwards L thing. It's the same as doing a fraction. It just does that in statistics mode. I don't know why, but we still get this. We still get the correct answer. Let's work out SYY now. And just to remind ourselves, that comes from the fact that we do the sum of y squared minus sum of y squared over n. So just plugging the values in, sum of y squared equals 8753 minus the sum of y to be squared. So it's going to be 229 squared over 6. And when we put that into the calculator, 8753 minus 229 squared divided by 6, we get 77 over 6, which is 12.83. 12.83. And then the sum of y squared comes from doing sum of x y minus the sum of x times by the sum of y all over n, and that gives us 7296.7. 7296.7 minus, well, the sum of x is 191.1, 191.1 times by the sum of y, 229, and that's all divided by 6. So let's put that into the calculator now. So 7296.7 subtract, and I'm going to do 191.1 multiplied by 229 divided by 6, and we get 3.05. And there's SXY, SYY and SXX. Okay, time for you to have a go now. So we've got the marks for 10 students who sat a maths and physics exam. Scores are recorded there. So work out SXX, SYY and SXY. Pause the video and give those a go. Okay, hopefully you've managed to do that. There are the solutions. So you should have written down the various pieces of information you want. Sometimes these are actually given in a question, which is nice. We don't have to do any calculator work or much calculator work. So sometimes all these red values are given, and then you just plug them into the formula, and there are the answers there. Okay, now another thing we can do is work out the strength of the correlation, and that's by working out the product moment correlation coefficient, R. And this tells us how strong the correlation is. So if it's positive, we've got a positive correlation. If it's negative, you've got a negative correlation. And the closer it is to 0, the closer it gets to 0, the weaker the correlation. So the closer we get to 0, the weaker the correlation. Do bear in mind that the R value is also extremely affected by outliers. Okay, so if we return to, say, this question here, and if I wanted to calculate R, let's just copy over the formula, which is also given in the formula book. So copying the formula over, and I'm going to hide it up here somewhere. Okay, there's two ways to do this. I'm also going to copy in the values that we had from earlier. So let's group all of that. and copy. And here we go. Excellent. Going to move that. Okay, so to calculate R, let's do it in green. It equals SXY, which we have here, 3.05, divided by the square root of SXX times SYY. So SXX is down here. So the square root of 18.855 times by SYY 12.83. You'll notice that I haven't been rounding these to three significant figures because I don't want to lose any of my accuracy from rounding early on. So we plug that into the calculator. I'm going to do 3.05 divided by the square root of 18.855 times by 12.83. Hopefully this works. 0.05. 0.05. In fact, let's give this to 3 sig fig now. 0.055. 0.055. Now another thing to note is that your calculator will actually do this for you. I don't particularly recommend doing this in the exam because it's nice to show the examiner that you can work out SXX, SYY, SXY, and then at least if something goes wrong you won't lose a ton of marks. But I'm pretty sure that we can use the calculator to work out R. So if I hit 1 and then stats and I hit var, it's not var. Let's try that again. 1 stat, sorry, 5 reg for regression, which we'll talk about in a later video. If I want to calculate R, which is 3, press 3. Let's hope this works. That didn't quite work out right. Don't know what's gone wrong in that sense. Anyway, my advice to you is calculate it using SXX, SYY, SXY. Show the examiner all your workings, and I am pretty certain that 0.055 is the correct answer for that question. Okay, time for you to have a go. So there are the values that you would have worked out earlier on. So calculate R now for this data set. Okay, so hopefully you've had a go at that. Let's just do this one as a group. So to calculate R, I should be just plugging in the values. I'm going to turn this back to regular mode. SXY is 2330.6, and I'm going to divide that by the square root of 2961.6 times by 1852.1, close the brackets, it equals, and we get 0.995. 0.995. You see it's a positive correlation, and it's also very strong because it's very close to 1. If it was 1, it's perfect correlation, perfect strong correlation. That means that the data would be in an absolute direct line. If it was -1, it would be perfect negative correlation. It's almost perfect, so it's very, very strong. Okay, that's all from me. You should now be able to have a go at exercises 6A and 6B from the textbook. Best of luck with the revision. I will talk to you again sometime. Bye for now.